Okay, my dear children, today we are going to discuss operation of taking square root of real numbers. Do you know any idea about square root of a number? Do you have any idea about square root of a number?
No, sir.
Square root of 4. What is the value of a square root of 4?
Sir, two.
Square root of
Two,
9.
sir.
Square root of 9.
Sir, three.
Square root of 16.
Sir, 8.
Sir,
Square root of
four.
16.
Sir,
Sir,
four.
4. Sir, 4.
Not 8. Square root of 16 is 4. So, you know some idea about square root of natural numbers. In earlier class, you have found square root of some natural numbers by prime factorization method and also by division method. Do you remember that one also? By using division method also, you have found square root of a number. Do you have any idea? Okay, prime factorization method. You know about prime factorization method. Yes or no? Prime factorization method. Now, square root. If a is a natural number, first let us recall the previous knowledge. If a is a natural number, if a is a natural number, if a is a natural number, then root a is equal to b. Then root a is equal to b. Just like root 4 is equal to 2, root 9 square root. Generally we read it as root, actually square root only, but for our convenient we read it as simply root. Root a means square root a only. Please remember this point, my children. So square root a is equal to b means it means b square is equal to a. Square of the number b is equal to a and b greater than 0. B also a positive number. B should be a positive number.
Good
This is
afternoon, sir.
good afternoon. Who said good afternoon now? Who said good afternoon?
Krish.
Huh?
Krish.
What, my dear Krish? Is this afternoon? Is this afternoon for
Good
you?
morning, sir.
Yes, good morning. Now, we are discussing the operation of square root of real numbers. So, first of all, we start with the natural numbers because natural numbers are the first kind of collection of numbers. So, if a is a natural number, then square root a is equal to b means the value of square root a is equal to b means b square is equal to a. B square is equal to a. So b square is equal to a. Here b also should be positive number. The same definition can be extended for the for the collection of real numbers also. Okay, my children, we extend the same concept for we extend the above definition for positive real numbers also. for positive real numbers also, we use the same definition. We use the same definition. So if a is a positive real number, then square root a is equal to b. Now let us write that definition. Let a greater than 0 means a is a positive real number. A is a positive real number. Then root a. Whatever we wrote here, the same definition is used here also. Then root a is equal to b means we use the same definition here also for real numbers also. Here we have defined square root, operation of taking square root on natural numbers. We use the same definition for real numbers also. So root a, square root a is equal to b means b square is equal to a, and b greater than 0. Okay, my children, this is about square root of real number. What, my dear Bibina? Do you want to
Sir, what is DEF, sir?
be?
Sir, what is DEF, sir?
B definition. DEF, short form, definition. I did not write the
Okay,
complete
sir.
word, definition. We are writing the definition of taking square root of real numbers. In the above 3 lines, in these 3 lines, we discussed the taking the square root of a natural number. We use the same definition for positive real numbers. Please remember this point, my children. We are taking the square root of a positive real numbers.
Sir, B should not be 0 or it can be equal also.
Now here, see there, what is the value of a here? What is the value of a? I kept my fingers here. What is the value of a? What is the value of a here? Greater than 0. Yes or no? If a is greater than 0, then b value also a positive real number, not 0. Here we have taken positive real numbers. We are not taking 0. Positive real numbers
Okay,
means
sir.
it may be 0 0.1, 0 0.2, 0 0.3, 0 0.4 like this. Understood this point, my dear Bibina? So here b also,
Yes, sir.
b value also automatically, its value is also automatically a positive real number. Okay, my dear Bibina?
No, sir.
What? What, my dear Bibina?
Good, sir.
Huh?
Sir.
What, my dear Bibina? For example, square root of 4 is equal to 2. Square root of 4 means positive square root only. Here we are taking only positive square root. Okay. That implies 2 square is equal to 4. Similarly, square root of 9 is equal to 3. That means, implies, what can you write here? 3 square is equal to 9. Similarly, square root of 16 is equal to 4. Square root of 16 is equal to 4. It means 4 square is equal to 16. Yes or no? What is the value of 4 square? 16 or not?
Yes, sir.
Yes. This is about only square root. About a square root. If we extend the root, cube root, fourth root, we can extend the root of a number. It is only square root. We can extend to that cube root, fourth root, fifth root. Previously I told you this is a square root. Okay, my children. Suppose another definition. Let a greater than 0. Suppose a is a positive real number. A is a real number and it should be greater than 0. Means a is a positive real number. The meaning of this entire sentence is a is a positive real number. And n be a. And n be a positive integer. N be a positive integer. Do you remember what are positive integers? Can you tell me? What are positive integers? What are positive integers?
So 1.
Tell me.
So 1 to infinity.
Yes, very good, my dear Santi. 1, 2, 3, 4, and so on. These are called positive integers. So here n is taking positive integers. Then nth root. Yes, very good, my dear Bibina. Nth root here under the in between this symbol n we have written. Please observe this point, my dear children. Nth root a is equal to b if b power n is equal to a and b greater than 0 and b greater than 0. And b greater than 0. How do you read this symbol, my dear children? Nth root of a, not n root a. It is different from nth root of a. Please observe here n, where I wrote here in between v symbol. Just I have written as v. Okay. In between this gap, in this space, I wrote n. Okay, this is read as nth root a. And this nth root is called radical sign. And a is called radicand. A is called radicand. For example, I will give you here some examples how to read them and what is a radical sign and what is a radicand. Okay. How do you read this one? Square root 7. Square root. How do you read this number, my dear children? How do you read this number? Square root 7. I wrote here clearly. Square root 7. It is read as, this number is read as square root 7. In this example, what is a radical sign? Square root. This is a radical sign. And what is radicand? 7. 7 is a radicand. See here, this is, okay, my dear Janej, very good. How do you read this number? How do you read this number? Cube root of 5, or simply cube root 5. Simply you can read it also. Read it as cube root 5 or cube root of 5. In this example, this cube root is a radical sign and 5 is a radicand. Observe these numbers, my dear children, where I am writing here 3, 4. Okay. No number is written here, so it is read as square root. Remember these. Okay, my dear children, remember these points. How to read. This is read as. No, my dear Janesh, in general, in the case of a square root, we don't write here 2. We don't write here 2. We omit. We ignore writing here 2. Okay. In general, we don't write here 2. But in the case of cube root, in the case of fourth root, okay, this is read as fourth root. This number is read as fourth root of 10. Remember these, my dear children, and learn well how to read a number. How to read a number. And here radical sign is fourth root. And the radicand is 10. Radicand is 10. And observe the numbers, my dear children, where I am writing here. 3, 4, 5. Don't write before this radicand sign. Before this radical sign, don't write these numbers. In between this gap only. Inculcate the habit of writing in correct place. Okay. This is read as fifth root of 35. In this example, radical sign is fifth root and radicand is 35. Radicand is 35. And so on. We can extend this concept. Sixth root, seventh root, eighth root. Okay. I will write one more example. Sixth root of 16. This number is read as sixth root of 16. And here radical sign is sixth root. And radicand is 16. One more time, all of you, one more time, read this one. My dear Ben Johnson, how do you read this number? How do you read this number? Ben Johnson, make it fast. Make it fast, my dear Ben Johnson. Ben Johnson, are you there online or not? Ben Johnson. Ben Johnson. You are not responding to my question. Ben Johnson, are you there online or not? My dear Eileen? Eileen?
Yes, miss. Yes, sir.
Yes. Can you read these numbers?
Which number? Which numbers?
Are you watching the screen or not?
Yes,
Are
sir,
you?
but it's blur for me. Actually, my net is very slow.
Okay. Who will read? Just raise their hands. Who will read these numbers? Just raise their hands, my dear children. Okay, my dear Shanti, read this number. Okay, my dear Shanti, down your hand. Down your hand.
Square root.
Yes.
So square root 7.
And this number. Wait, yes, my dear Bibina.
Cube root of 3. Of 5.
Ah,
Fourth root of 10.
yes.
Fifth root of 35.
And last one.
Sixth root of 16.
Very good. Have you heard how to read these numbers, my dear children? Yes, my dear Bibina. Yes, fifth root of 35 and sixth root of 16. You must learn how to read these numbers and what is a radical sign. Yes, 100th root of 1000. Like these can example. These are some example. Okay, I will take that example also. 100th root of 1000. Observe these numbers, my children, where I am writing here. Okay. Please remember that place. Where should we write these numbers? When you are writing 100th root, 6th root, 5th root. Okay. And the radicand is 1000. This is about a radical sign, radicand, and how to read the numbers. Okay, my children.
Okay, sir.
Now we discuss some properties of square roots of numbers. We use these properties in the next exercise. Okay. Let A and B let B A and B be positive real numbers. My dear children, are you ready to write weekly test this week? This week.
Yes, sir. Yes, sir.
Yes, sir.
Okay. For 15 marks. For 15 marks. Be ready. Can I conduct that weekly test on Saturday? This is Saturday.
Okay, sir.
Okay, sir.
26th. I will tell you time. I will tell you time. Okay.
Sir, actually, we have a period as new general test on Wednesday last period. We don't have actually any time. That time you could have made the test, right?
I will Wednesday. You have
Last period.
last periods. Wednesday.
Yes, Wednesday last period. It's free for us.
I will note it down.
So
Last
what
period
is
is 3:30 to 4:15.
Yes, sir.
You mean 3:30 to 4:15. Okay.
Yes, sir.
So
Sir, and
everybody.
then Tuesday, 2:30 to 3:15 also it is given only test. Which subject tested or it is not mentioned.
Okay, Tuesday timing 2:30.
So 2:30 to 3:15.
Sorry, 2 to 2:45. Yes or no? Or 2:30 to 3:15. Okay.
Yes, sir. Sir, but I don't know which test will be conducted. It is
Okay. But
given
these
only
two
test.
but these two periods were mentioned for weekly tests. Yes or no? These two periods.
Sir, weekly test and all, it is not mentioned in the timetable, sir.
Not to mention in the timetable. Uh-huh. Okay, I will check out my timetable also. If I am free in this time, I will conduct the test. Otherwise, in case I have classes, if I have classes in these two periods, in that case, I will conduct on Saturday. I will conduct the test on Saturday.
Sir, can we have class on max period itself, sir?
In mass period itself means we lose the teaching periods. We lose the teaching periods. Yes or no, my dear Bibina? If we conduct, if you write the exam, if you write the weekly test in the mass period, you will lose the teaching periods. There are much portion is there. Much portion is there in ninth class. You have to learn more because this is a little bit foundation for 10th class. Yes or no? If you learn concepts well in this class, then it will be easy for you to study 10th class maths. Okay, I will plan it. I will plan this week. I will plan to conduct this week. I will let you know. I will let you know, my dear children. Don't worry. Uh, how many exercises can you practice well? If I plan a weekly test this week, how many exercises can you prepare well? Please tell me how many exercises. So far we have completed 1.4 exercise. 4 exercises were completed so far in this chapter. How many exercises can you prepare well? If I plan a weekly test in this week. 3 okay, all of you. 3 exercises okay for all of you. Mahima told first. Mahima responded first that 3 exercises. All of you okay for that?
First three exercises.
Yes, 1.1, 1.2, 1.3.
Okay, sir.
1.1, 1.2 and 1.3. 3 exercises. Whatever I explained in the classes based on that concepts. Don't expect the same questions. Don't expect the same questions. You should learn the concepts only, not problems. Problems are meant for practice. Okay. But you should learn concepts well. Okay, my dear children. Is it okay for all of you? 1.1, 1.2 and 1.3 exercises for weekly test. Okay. Be ready
Okay, sir.
and be ready. Prepare well. I will let you know the time and date of the test. Okay. Now come to this point. Let A and B be positive real numbers. They are positive real numbers. Then root AB is equal to root A into root B. You have learned these properties in a earlier class. Root A into root B is equal to root AB. We use these properties in solving the sums. Square root of A by B. Square root of A by B. Square root A by square root b. If you want to find the square root of a fraction, in that case we can take square root of the numerator separately and we take the square root of the denominator separately. After that we divide. Okay, next third one, root a plus root b, root a plus root b into root a minus root b. If you multiply these two expressions, can you do this one and tell me the answer? Multiply these two expressions. If you observe this one, it is in the form of x plus y into x minus y. Yes or no? X plus y into x minus y. That is an algebraic identity, x plus y into x minus y. What is the formula? Do you remember that algebraic identity, my dear children? X plus y into x minus y is equal to, who will tell the answer? X plus y into x minus y is equal to. Just raise your hands. Who knows?
Sir, x square
X square?
plus abx
No.
plus a into b, sir.
No. X plus y into x minus y. X plus y into x minus y. X square minus y square. That is a identity, algebraic identity. So where x is equal to root a and y is equal to root b. So by using that algebraic identity, we get root a whole square minus root b whole square, because x plus y into x minus y is equal to, we have used this algebraic identity, x plus y into x minus y is equal to x square minus y square, where x is equal to root a and y is equal to root b. Understood this step, my dear children? Then we can strike out square and square root. If you strike out square and square root, what will you get in this first term? If you strike out square root and square, what will you get here in the first term? What will you get? Yeah, very good. Minus. Now come to the second term. What will you get? Here also we follow the same rule. Cut the square root and square root symbol and square. What will you get here? Second term, what is the b? Yes, very good. So root a plus b into root a minus b is equal to a minus b. Actually, this is an irrational number. Previously, we have discussed in the last class, we have discussed an irrational number plus another irrational number. Sum of two irrational numbers or difference of two irrational numbers is also an irrational number. So, this is an irrational number and this is an irrational number. But product of these two, the product of these two irrational number is not an irrational number. This is called a rational number, because there is no square root to sign. There is no square root to sign. There is no radical sign. So this is called a rational number. So please observe root a plus b, root b. For this irrational number, root a minus root b is called a rationalization factor. For root a plus root b, root a minus root b is called a rationalization factor. And for root a minus root b, for this number root a minus root b, this number is called a rationalization factor. Vice versa, this number is a rationalization factor of the second number and the second number is the rationalization factor of the first number, because the product of these two numbers is a rational number. That is called, these numbers are called rationalizing factor of the other number. Okay, my children. Now, please remember this result. Please remember this result. Similarly, a plus root b into a minus root b. Here also, if you observe, a plus root b is an irrational number. A minus b is also an irrational number, because a rational number plus an irrational number, the sum of a rational number and an irrational number is always an irrational number. Similarly, difference of a rational number and an irrational number is also an irrational number. Here we are finding the product of these two irrational numbers. If you observe these two expressions, these are also in the form of x plus y into x minus y. So here also we can use the same algebraic identity, where x is equal to a and y is equal to root b, where x is equal to a and y is equal to root b. So we use that algebraic identity, x square, that is a square minus root b whole square. By using the algebraic identity, x plus y into x minus y is equal to x square minus y square. By using the same algebraic identity, we wrote this step. Now, can you tell me what is the first term? Can you tell me, any one of you, what is the first term? After simplifying the first term, what will you get here? What will you get here?
Sir, a square.
Very good, my dear Bibina. A square minus, what will you get second term? What is the second term? Can you tell me?
So b.
Huh? Yes, b. Because square root sign and square gets cancelled. Then we will cut square root sign and square. Then we get only b. So, if you observe this number, a square minus b is a rational number. It is a rational number. So, by multiplying these two irrational numbers, previously I told you this is an irrational number and second number is also an irrational number. By multiplying these two irrational numbers, we got a rational number. That is why the first number is called the rationalization factor of the second number, and the second number is called the rationalization factor of the first number. I will prepare a table for rationalization factors. Don't worry about it. Just remember these points. Okay, my children. Now come to this next one. Root a plus root b. Root a plus root b into root c plus root d. Now, can you multiply these two expressions? Here, we cannot use any algebraic identity. Here, if you observe these two expressions, we cannot use any algebraic identity. Now, can you multiply these two expressions? Anyone can multiply these two expressions? Anyone? Root a, take the first term and we write the second expression as it is, root c plus root d, plus second term in the first expression, that is root b into root c plus root d. Just I used here distributive property. Distributive property. Now at least can you tell me here, how can you multiply these two expressions, root a into root c plus root d? What will you get here, root a into root c? Root ac, because we used this property, root a into root b is equal to root ab. So root a into root c is root ac plus root a into root d, root ad, plus similarly here multiply these two expressions. Can you tell me, anyone, how can you multiply? What will you get here by multiplying these two expressions? Anyone? Just I multiplied here. Follow the same procedure here also. Follow the same.
So root BC.
Yes, very good. My dear Srujana, root BC plus next Srujana, can you tell me next one? Root B into
So
root D.
root BD.
Yes, very good. Root BD. This is the resultant product of these two irrational numbers. This is an irrational number. This is also an irrational number. But the product of these two irrational numbers is also an irrational number. Okay, my children. So you have to learn these points. These are useful for the next exercise. Now, rationalization factor. What is meant by rationalization factor? If a number is a irrational number, we have to find another number y. Suppose x is an irrational number. Suppose in your mind, let us consider this is x and this is y. If x is an irrational number, we have to multiply this irrational number with an irrational number to get the product a rational number. Then the number y is called rationalization factor. Rationalization factor. Okay, we will discuss this point in the next class, my dear children. In the meantime, all of you write the classwork notes. Are you writing the classwork notes and submitting them in the Google Classroom?
Yes, sir.
I will find out who are not submitting their classwork notes regularly. Please remember this point, my dear children. Submission of your classwork notes also will be considered for your internal marks. Your internal marks will be affected if you are not submitting your work on time. Okay, my dear children, please remember this point. Now, prepare well for the Google test. Yes? What, my dear? Krish? Yes, so now the time is 9 past 44 minutes. Okay, please remember exercise 1.1, 1.2 and 1.3. These three exercises are the portion syllabus for the weekly test. Okay, my children, please remember and practice it well. Practice these three exercises well. And I will let you know the date and time of the test. Date and time of the test. Okay, my children. Now the time is 9 past 45 minutes. You can leave the meeting, my children. Take rest. Take care of your health, my children. Stay at home. Stay safe.
Thank you, sir.
Sanitize
Thank
your
you, sir.
hands frequently. Use mask. Use mask. Sanitize your hands frequently. Maintain social
Thank you,
distance, my
sir.
children. Thank you all, my dear children, and do your work sincerely. Submit your work in the Google Classroom on time. Don't delay in submitting your work in the Google Classroom. Your internal marks will be assessed on the basis of your classwork notes, homework sums submission. Okay.
Thank you.